today we will be looking at radical inequalities. And so the problems that we're going to see today are going to look something like this. So we'll have for these something like the square root of 2x minus 7 is greater than or equal to 5. And so whenever we're solving these equations, they're going to be a lot quicker than solving the radical equations that we looked at. Sorry, these are inequalities, not equations. The inequalities are going to be a lot quicker than the equations that we did in class, mostly because I'm going to give you problems that are a little bit more simple. And as we solve these, there is just something special that we have to keep in mind, and that is domain. So whenever we're looking at square root equations, our domain tells us that anything under the square root must be greater than or equal to 0. I cannot take the square root of a negative number. So for this particular problem right here, before I even begin the problem, I want to keep in mind that 2x minus 7 has to be greater than or equal to 0. So in that case, that means that 2x has to be greater than or equal to 7, and I could divide by 2 here. And so x has to be greater than or equal to 7/2. So this is part of my answer. We're going to use it after we solve the equation. So the inequality, I keep saying equation here. So when we want to solve this inequality, we're just going to square both sides of the inequality. And when we do that, we get 2x minus 7 is greater than or equal to 25. And then we are going to add 7 to both sides. So 2x is greater than or equal to 32. And last step here, divide by 2. So x is greater than or equal to 16. And so what we want to do here for our answer is we want to look at our answer in conjunction with our domain. So let's begin with our domain. Our domain tells us here at 7/2 that we are only going to look at numbers that are either 7/2 or above. Okay, so this is the domain. And then we also need to look at our solution. And so our solution, we got 16 here, and we're looking at numbers 16 and above. And so your answer is the places where these overlap. Well, in this particular case, for a number to be greater than or equal to 16, it has to be greater than or equal to 7/2. So in this particular case, these are just going to overlap up here, and we know that our answer is just x is greater than or equal to 16. So that is our final answer for this problem. However, we're going to see in the next problem that is not always the case. So let's do another problem here. For example 2, let's do this equation. The square root of b plus 4 is less than or equal to 6. And whenever we look at this problem, we first need to think about that domain there. So our b plus 4, that value has to be greater than or equal to 0. Otherwise, you get a negative under the square root, which tells us that b has to be greater than or equal to -4. So this is important for us to keep in mind. If we get any numbers less than -4, then we're going to have to throw those out. And so we're just going to go ahead and solve this equation, this inequality, like we would an equation. And that's going to give us b plus 4 is less than or equal to 36. And if we subtract that 4 from both sides, we get b is less than or equal to 32. So look at how this plays out here. So I know that my domain here, I'll put -4 and 32 here on my number line. My domain is that b must be greater than or equal to -4. And I also know that my solution here is b is less than are equal to 32. And so whenever I look to solve this, I'm looking for the overlap between the two answers, which happens right here in the middle. So my answer for this, I can either write -4 is less than or equal to x less than or equal to 32. That's probably how you're going to see the answer written, at least in the book. Actually, it won't have an x there because this variable here was a b, so it'll be less than or equal to b less than or equal to 32. You might see it with interval notation, but I think this is probably what you're going to be looking at. Our answer here was anything less than 32, but of course we have to consider that domain, because if I plug in -10, -10 plus 4 is going to give me a -6 underneath that square root, which is imaginary, so it cannot be a solution. So we have to keep that domain in check whenever we do these problems. Not always, but typically you're more likely to see that there's an issue whenever you have a less than or equal to. Greater thans don't typically give you as much trouble. All right, let's do another problem. So for example 3, we've got the square root of a minus 5 is less than or equal to 4. So again, domain, we know a minus 5 has got to be greater than or equal to 0. Otherwise, we get a negative underneath the square root. So that tells us a is greater than or equal to 5. We have to keep that in mind. Then we're going to solve this inequality here by squaring both sides. So a minus 5 is less than or equal to 16 if we add that 5 to both sides. I don't know why it doesn't let me write 5. A is less than or equal to 21. And so if we think about our answers here on the number line, we've got 5, we've got 21, and for our domain, a has to be greater than or equal to 5. But for our answer, for our solution, we get a is less than or equal to 21. And so that overlap we can see happens right there between those two values. So we would write our answer as 5 less than or equal to a less than or equal to 21. For example 4, we are going to have the square root of 2x minus 5 plus 2 is less than or equal to 8 here. And so this one is a little bit different because we've got this plus 2 out here on the outside. Don't panic though, this is not as difficult as the equations that we were dealing with the other day. We can fix this problem right here really simply by just subtracting 2 from both sides, which is going to give us the square root of 2x minus 5 is less than or equal to 6. And so from here, if we think about that domain, 2x minus 5 must be greater than or equal to 0. So that tells us 2x must be greater than or equal to 5. And then if we divide by 2, x is greater than or equal to 5 divided by 2. So if we continue solving here, if we square both sides, we get 2x minus 5 is less than or equal to 36. We can add 5 to both sides, and so 2x is less than or equal to 41, and we'll divide by 2 here, and I'm just going to leave that x is less than or equal to 41 over 2. If you want, you can go ahead and get 20.5 there. Either one is fine. And so whenever we do this, we have to think about our number line, and we know that we've got a 5 halves here and a 41 over 2 here, and x has to be greater than or equal to 5 halves, so that falls here. But 41 over 2, we have to have x also has to be, I used the wrong colors here, those are backwards, has to be less than or equal to 41 over 2, so we're looking at our answer in between. So we would say 5/2 is less than or equal to x, which is less than or equal to 41 over 2. And that would be our answer for this inequality. All right, let's continue on with just a couple more examples. For example 5, we have the fourth root of 5y minus 9 is less than or equal to 2. So here we've got a fourth root instead of a square root. So whenever we have a fourth root, in order to undo a fourth root, we have to raise that to the fourth power. But much like a square root, any even root is still going to require that whatever is underneath the square root, or in this case the fourth root, has to be greater than or equal to 0. So 5y minus 9 must be greater than or equal to 0, which tells us that 5y is greater than or equal to 9. So y is greater than or equal to 9/5. Now, if we solve this, instead of raising each side to the second power, we're going to raise each side to the fourth power, because a fourth root and raising something to the fourth power is going to cancel each other out, and you'll just be left with 5y minus 9 is less than or equal to 2 to the fourth power, which is going to give us 16 here. And so now we have a simple inequality to solve. We're going to add 9 to both sides. 5y is less than or equal to 25. And we're going to divide by 5. Sorry, this is a mess. I don't know why it's doing this. So y is less than or equal to 5. If you think about the number line here, 9/5 is going to be like 1.8. So it would be down here. And then 5 would be up here. So we have to have a value that's greater than or equal to 9/5. But it also must be less than or equal to 5. So our answer is this overlap right here in the middle. And so we would say that our answer is 9/5 less than or equal to y less than or equal to 5. And that would be our solution. I've got a couple more problems that I want us to look at. So, actually maybe 3. So, for example 6, let's do the square root of m plus 2 is less than or equal to the square root of 3m plus 4. So this problem is a little bit different than the ones that we've looked at so far. We've got 2 domains here to consider. So we know that m plus 2 has to be greater than or equal to 0, which means that m has to be greater than or equal to -2. We also must consider that 3m plus 4 has to be greater than or equal to 0, which of course means that 3m is greater than or equal to -4. And if you divide by 3 here, then m is greater than or equal to -4/3. So we're going to just keep that in the back of our mind. We're going to go ahead and solve here. So in order for the square root of m plus 2 to be less than or equal to the square root of 3m plus 2, then m plus 2 has to be greater than, less than or equal to 3m plus 4. So it will be acceptable here for us to just square both sides, which is going to get rid of both of those square roots. So we'll have m plus 2 is less than or equal to 3m plus 4. And now we've just got to solve that inequality. So we're going to subtract m. And so 2 is less than or equal to 2m plus 4. We can subtract our 4. And so we get -2 is less than or equal to 2m, and divide by 2 here. So negative 1 is less than or equal to m. I'm going to rewrite this as m is greater than or equal to negative 1. If I flip this around, remember I've got to flip that sign there. So we're going to consider our number line here. And we've got negative 2 would be our lowest number. Negative 4/3 is like negative 1.3 repeating. And then we'd have negative 1 would be here. So our domain, here we've got that m has to be greater than or equal to negative 2. We also have that m has to be greater than or equal to negative 4/3. Notice if a number is greater than or equal to negative 2, it's also greater than or equal to, if a number is greater than or equal to negative 4/3, it's also greater than or equal to negative 2. And then our solution that we found here was m is greater than or equal to negative 1. And so for this, we're looking for where all three of those overlap, and that only happens right here, meaning that m is greater than or equal to negative 1 is our answer. In this case, m is greater than or equal to negative 1 would require that m is also greater than or equal to negative 2, and that it's also greater than or equal to negative 4/3. So it's okay just to give this as our answer. All right, let's look at another one. Okay, our next example, example 7, is going to be 2 square root of x minus 8 is less than or equal to 14. And so to solve this problem, again, we still need to think about domain, but we're only thinking about what's underneath that square root, which in this case is just an x. So we know x must be greater than or equal to 0. Now we're just going to solve our inequality, so we're going to add that 8 to both sides. So we're going to get 2 square root of x is less than or equal to 22. We can divide that 2 there from both sides. So we've got the square root of x is less than or equal to 11. Now we want to square both sides here, so that tells us that x is less than or equal to 121. And so if we're thinking about our answers here, we know that x has to be greater than or equal to 0. That falls here. And then we also know that this x has to be less than or equal to 121. So that overlap occurs right here in the middle. So we would say that our answer is 0 less than or equal to x less than or equal to 121. Okay, I've got one more problem that I want us to look at. So for example 8, we're going to have the square root of x plus 2 is greater than or equal to 3 times the square root of x. Actually, let me put a 3 right here. And so for this problem, we actually have two different domains that we have to look at, just like example 6. So we've got 3x plus 2. 3x plus 2 must be greater than or equal to 0, which tells us that 3x is greater than or equal to negative 2, and that means x is greater than or equal to negative 2/3. We also have this x right here, so that tells us x has to be greater than or equal to 0 also. So we're just going to keep those in the back of our mind for right now, and we're going to solve this inequality. Now when we solve this inequality, we need to square both sides, and it's a little bit more complicated than the ones we've done so far because we've got this 3 over here on the outside of the square root. On the left-hand side, the square root of 3x plus 2 squared is just going to be 3x plus 2. But over here on the right-hand side, this is 3 times the square root of x. So because these two things are multiplied, we can square them separately. So 3 squared is 9, and the square root of x squared is just x. And now we have an inequality that we can solve pretty easily. We're just going to subtract that 3x right there. And 2 is greater than or equal to 6x. We're going to divide by 6 on both sides. And so we've got 1/3 is greater than or equal to x. We also can write it this way, x is less than or equal to 1/3. So if we put this onto a number line here, then we are going to look at, we've got -2/3 would be here, 0 here, and 1/3 up here. And x has to be greater than or equal to -2/3. It also has to be greater than or equal to 0. Notice that anything that is greater than or equal to 0 is also greater than or equal to -2/3. So really this x is greater than or equal to -2/3 becomes unnecessary at this point. And then x is less than or equal to 1/3. So x is less than or equal to 1/3 is here. And remember, we're looking for where all three of these overlap, which happens right here. And so this is going to be 0 is less than or equal to x less than or equal to 1/3.